This is Gagan Girotra, IIT Roorkee class of 2000, and I am Calcutta class of 2005.
In problems around circular motion, the problems typically they take two shapes. The first is that two objects moving around a circle, they start at the same point and they meet anywhere, right? So we got to find out what exactly is the point in time when they meet for the first time. The second kind of problems is that they start at the same point, right? And they meet at the starting point itself, right? So here we are not restricting where they meet. Here we are restricting that they meet only at the starting point. Now both of these problems will be attacked using different concepts. The first one, meet anywhere, will use the concept of relative motion or relative speed, right? This is the concept we are going to use. But meet anywhere, we are going to use the LCM concept. Now this is going to be a very straightforward thing. The way we go around doing this thing, let's look at this situation first. So let's say there is this circle around which two people are going to be running, and let's say they start from here, right? So A, B, they are two people, and let's say they both start running in the same direction, right? So A starts running in this direction anti-clockwise, B also starts running anti-clockwise. The question we are now trying to answer is, when will they be together at the same starting point, right? So the answer to this is fairly straightforward. If we are able to calculate the time that A takes to complete one circle, right? Let's say A takes, let's say 30 seconds to complete one full circle, right? So that means every 30 seconds he's at the starting point. So 30, 60, 90, 120 and so on is the point in time when A will be at the starting point. Likewise, let's take the example, let's take for example B takes 45 seconds to complete this one full circle, right? That means B is going to be at the starting point at 45th second, then at 90th second, then at 135th second and so on, right? So A is at the starting point at time equals 0 seconds, B is also at t equals 0 seconds at the starting point. Then A continues to come to the starting point every 30 seconds. That means A is at the starting point at 30, 30, 60, 90, 120 and so on, right? So it's all the multiples of 30 seconds that A is at the starting point. Likewise, B is at the starting point at all the multiples of 45, right? So B is at the starting point at time equals 0, then time equals 45, then time equals 90, then time equals 135 and so on, right? So essentially A and B both are going to be at the starting point at the LCM of 30 and 45, right? So the LCM of 30 and 45 being 90 means that A and B are going to be at the starting point for the first time at time equals 90 seconds, and 90 is the LCM of 30 and 45. Now you may notice that it does not matter whether they are both running in the same direction or they're both running in the opposite directions, right? So the answer is going to be always LCM of the times, their respective times, right? Irrespective of which direction, right? So direction has no impact on the answer on when they meet, right? So this is a fairly straightforward thing to approach, that finding out when two people running around a circle in the same direction or the opposite directions, they meet at the starting point. The answer is just going to be finding the LCM of their respective times to complete the circle. But when we look at circular motion, right, and we allow them to meet anywhere, then what works for us is relative speed, right? So in case of relative speed, what we will do is, let's look at a situation when there are these two people who have to move around a circle, right? So let's say these two people, A and B, they start from this point where I've drawn a cross, right, and they move in the opposite direction. So let's look at the case when they move in the opposite directions. right? So A moves counterclockwise and B moves clockwise, and let's say depending on their respective speeds, they end up meeting at this point, right? So I've drawn another cross here. So at a certain point in time, they have both met here. Now, if I have to find the time that they take to meet, essentially what I need to do is I need to use relative speed because it makes my life easier. Just imagine that you cut this thread, right? Cut this circular thread from here and get A and B to stand back to back and open this thread up, right? So it will probably look like this, right? So what I've done is I've cut the thread at this cross, right, and I've stretched this thread open into a straight line. So essentially what I've done is this starting point is now split across this point and this point, and A is starting from here and B is starting from here, and they are now moving in the opposite directions towards each other, and they are going to meet here. Now you notice that what we've done is we have simplified this problem into a relative speed problem with A and B having to cover the distance equal to circumference. You would notice that this length equals the circumference of the circle. So if let's say the circle around which they're running has a circumference of 300 meters, then the distance that A and B must commute is 300 meters, right? We take the speed of A as SA, we take the speed of B as SP, and just as the basic concepts of relative speed define, the time taken for both A and B to meet at this point or this point will be distance divided by the sum of their speeds, because this is relative speed. They're both their speeds are going to be added because they're moving in opposite directions. So this is the amount of time that A and B will take to meet anywhere on the circumference for the first time, right? So this now becomes a fairly straightforward problem of relative speed, where, remember, we have not put any limitation restriction on where they meet. It's just that whenever they do, that's the first time they meet anywhere on the circumference. Now let's look at the second situation. Now in the second situation, let's say they're both moving in the same direction. Now if they're moving in the same direction, right, then it may be a little difficult to imagine, but if let's say this is the starting point and both A and B, they start in the same direction, right, and immediately let's say B is faster and right away overtakes A, right, and they continue to take, you know, whatever number of rounds, and let's say they meet somewhere, right? Now what has happened is, let's say to have met here for the first time, let's say A has completed let's say 3.5 circles, right? So let's say A has completed, I'm just taking a hypothetical situation, that when they meet here, right, so A has completed approximately 3.5 rounds, right? Now if let's say B has been faster, right, and for A and B to be here at the same point in time for the first time, then B has to have completed exactly one more round than A. Think about it. If B takes off faster right away, right, and A is slower, and B is actually having to catch up with A, and let's say B catches up here, then the number of rounds that A has taken, B has taken exactly one more round, right? So now when we use relative speed, when we use the concept of relative speed, the relative distance or the relative gap that B has covered with respect to A is exactly one circumference, yeah, one round equivalent, right? Because no matter where they meet for the first time, B has taken exactly one extra round over A to be able to meet, right? So relative distance becomes one round, and obviously the relative speed is this time the speed of the faster minus the speed of the slower. Now because they're both moving in the same direction, the relative speed concept tells us that the difference of their absolute speeds is going to be the relative speed, right? So clearly the time when they meet for the first time, if let's say this circumference was again 300 meters, then the time that they will take to meet for the first time is going to be one circumference divided by the difference of their speeds.
Thanks for watching the video. You can give your feedback in the comments section below. Please click the like button if you thought the video was helpful. For lesson updates, you may subscribe to my YouTube channel People Plus, or you may read my blogs at peopleprep.com, or you can directly connect to us through our Facebook page @PeoplePlus, or you can email to me at gagan@peopleplus.com. Thank you.